But after this, position is can be calculated, right? Yeah. Yeah. So that's currently we just restrict our attention to a two-parameter family. So this two-parameter family of flows. With S, E from the interval I, from some interval I. Yeah, so we can look at more properties. So next, there is a very important semi-group property of this flow. So let's just write down this assumption and the conclusion. So here in this theorem, semi-group property for non-autonomous flows. Yeah, so our assumption is the same as before. This phi is just the flow generated by the vector field x, capital X. So that's the flow. So in this theorem, phi the flow generated by the time-dependent vector field x. Okay, x is from set B to Rn. Also, we suppose this point Sx, that's the point from B, and T is from the interval, right, the maximum interval. So this is the point. We know there's a integral curve, right? Maximum integral curve. Nothing is this point, which is defined on this interval. So we know T is from that interval. If that's the case, then this there are quite a bit notations in this section. So I want you to make sure you understand the meaning of the notation before we. And let's just write down the statement first. For every U, okay, so this theorem, yeah, so again, that just says that we have a flow defined on the time dependent vector field, right? For this flow, this means what? A point, right? s, or this is the time parameter. This is this s, this is the position, right? So that's the point from the vector field, the domain of the vector field B. A point from B, and t is also another time from the interval. Then that's the conclusion. This interval equals that interval. Yeah. What does that mean to you? What is this interval? This is pretty clear, right, from notation.
So we're using the identity function there. Like implicitly sort of.
Yeah, what this interval is clear.
Yeah.
Do you have a question? Huh?
Yeah, but then
Yeah.
like if it's t and s,
Yes.
then phi of st is just phi of ss, which gives you x.
Yeah, you don't. This
Okay.
one is at time t.
Okay.
Right. This one means the curve, right? The alpha, that's the solution curve, passing through this point. Yeah. Yeah. So that curve evaluated at t, right?
Okay.
Yeah. So it's just that curve using this as the initial condition, right? Yeah. So this notation means that's the initial condition of the initial value problem, right? This means this is the initial condition of the initial value problem. Yeah, this I just means the maximum interval of existence for this initial condition, right? So that's the notation. This means if we are looking for solution satisfying this initial condition, there's a maximum interval of existence. If you're looking for an integral curve satisfying this initial condition, there's a maximal integral curve, right, defined on this interval. So we're saying this interval is same as that interval. Yeah, it's just another point, t, right, of the integral curve, basically, passing through this point. So if you use that spot at a different time moment, use that as an initial condition, the two intervals are the same. Actually, the solution corresponding to this initial data and this initial data will be the same also. So this notation means, isn't that at t, right? T, you see, this is the position at this time, right? Yeah, which is just like how you put s, this is at this time, that's the position, right? That's a point from B, right? This is also a point from B, which is, so this is just another time. It's still a point from B. Yeah, so this, for this point, what is U? U is still time. You see this position is a time, right? ST. Right now, instead of using T, I use a U. It's just another time, which might be different than T or S, maybe the same, right? So it's just a time. Yeah, so that means the curve with this initial data at this time, right? This is the curve with this initial data. At time t, we have also some value, right? That's the initial data. So that initial data at this same time, they're the same. So the curves, the integral curves will be the same if we fix the sx. Yeah. Okay, so let's. And still, this